All right, hi folks, this is Larry Mussolino. I'm recording a video and I wanted to give you some background on working in Objective 2. In Objective 2, there's 5 topics and you can see they really have to do with factoring, mostly factoring quadratic expressions. Now, a quadratic expression is an expression that has a x squared in it. It's the variable to the exponent 2. That's what makes it quadratic. So here's a typical example. We'd like to factor this expression here. Now, remember the word factor means rewrite as a multiplication. So what they're asking us to do when they say factor this expression, they really mean rewrite it as a multiplication. So what we're going to end up doing is trying to rewrite this as 2 parentheses multiplying each other. All right, well, factor really is the opposite of multiplying. So before I do this example, let me just show you a multiplication problem, because if you can understand the multiplication process, it really makes the factoring easier, because remember, factoring is like the opposite of multiplying. So let me give you a quick example. Let's say I have, let's say 3x plus 5 multiplying x plus 4. All right, well, you probably remember how to do this multiplication. We use a FOIL kind of multiplication. What that means is take this first expression here, 3x, and let it multiply each one of the quantities in the second parenthesis. So 3x times x is 3x squared. And then 3x times 4 is 12x. Now I come back and do the same thing with this 5. I let the 5 multiply the x, that's 5x. And then I let the 5 multiply the 4, that's 20. Then I combine like terms, so I end up here with 3x squared plus 17x plus 20. All right, now remember, we're going to factor these kinds of expressions. So if I was going to factor this now, I'd want to rewrite it as the 2 parentheses being multiplied. Well, here's one way to get started. Notice here I have a 3x squared. What 2 quantities multiplied together to get me that 3x squared? What was the 3x from this first parenthesis and the x from that second parenthesis? So that's going to give me a clue about what quantities to put in front here. I know these 2 quantities have to multiply together to get me 3x squared. Well, for example, I would try and use maybe 3x and x, because 3x times x would get me back to the 3x squared. Also notice it was this 5 multiplying the 4 that got me this 20 back here. So when I go to try to figure out the numbers in the back of the parentheses, these 2 boxes would have to multiply to get me 20. Well, there's a couple of different ways to get 2 numbers to multiply to 20. I could do 4 times 5. I could do 2 times 10. I could also do 1 times 20. So these are some options that I would have to check out if I was going to do the factoring. All right, so let's use that as background to go and work on this example. Now, let me also bring up the reference packet. And if I bring up this reference packet, I just wanted to show you that there's 2 methods to use. One is called trial and error method, and another method is called the AC method. Now you can use whichever one of these methods you want, because you'll get the same answer either way. I'm going to use this trial and error method now, and in a minute I'll do another example where I use the AC method. But let's use this trial and error method to begin with. All right, so I want to factor this. I'm going to start writing it as 2 parentheses being multiplied. All right, let me come over here. I'm noticing this is a 2x squared. So I need, in these front boxes, I need these 2 boxes to multiply to get me 2x squared. Well, for that, I'm going to start off putting a 2x in this box and an x in that box. Because I know when I multiply those back, I'll get this 2x squared that I need to end up with. All right, let me go to the boxes in the back of these parentheses. Well, these two boxes have to multiply to get me this constant back here. So I need these two boxes to multiply to 10. Well, there's a couple of possibilities. I could use 2 and 5 because those multiply to get to 10, or I could use 1 times 10. So those are two options, okay? So notice what it says is construct two binomials. And in the front, we're putting the factors of 2x squared in my example. And in the back, we're putting the factors of 10. And it says, test each combination of factors until you end up with the correct answer. Our correct answer is going to need to have a plus 9x in the middle. All right, so here are my options that I could try. I could build this up with 2x plus 2 and x plus 5. So I'm using this first combination right now. But it turns out I would get a different answer if I switch those back numbers around. So I also have to check 2x plus 5 and x plus 2 as well, because that's going to give me a different middle term. What if I use the other combination of 1 and 10 in the back? Well, I got to check that out too. So another possibility is 2x plus 1 and x plus 10. But I also have to swap those back numbers as another possibility. All right, so now I have 4 options. I'll call them A, B, C, D. These are the only 4 possibilities to factor this expression. How do I know which one of these options, A, B, C, or D, is the correct one? Well, I know that in the middle, I need 9x as the middle term. So let me see which one of these gives me 9x. Now, what if none of them give me 9x? Well, if none of them result in 9x in the middle term, that tells me that this expression could not be factored. And if an expression can't be factored, we call it prime. All right, well, let's check it out. Now, to do this check, I know that 2x times x gets me to 2x squared. And then I'm going to do 2x times 5. Well, that's 10x. And then I'm going to come back this 2x. 2 times x is 2x. And then the 2 times 5 is 10. Well, it looks like this combination didn't work, because in the middle here, I'm getting 12x. But that's no good. Remember, we need 9x in the middle. All right, let me check the next one. Now I can take a little bit of a shortcut because all I really care about is the middle term. So I'm just going to think about 5 times x here. That's going to be 5x. And then 2x times 2 is 4x. Of course, I would still have 2x squared in front and 10 in the back. Well, now notice this middle term is 9x. So that tells me that choice B is the correct choice. I don't even have to bother checking choice C and D, because once I find the correct answer, there's no point in checking other options. So I know the answer to this question is 2x plus 5 times x plus 2. And I know that's the correct answer because when I multiplied those two parentheses back, I got the starting expression, which is a double check that my factoring really was correct. All right, so what I did here is I really listed out all possible combinations of how the factoring would work, and then I checked which one of the 4 options here gave me the correct middle term. Now, in some examples, you might end up with more than 4 options. So this method can get a little messy, depending on the numbers involved. So let's go to the AC method, and maybe we could do an example there. And sometimes that's a little quicker depending on the starting expression. So let's take a look at an example there. And in fact, Alex actually asks you to do the factoring using the AC method. Notice it says factor by grouping, which is called the AC method. So how does this work? Well, let me come down here to the instructions. All right, step 1, factor out the greatest common factor. Well, it turns out there really is no common factor to be factored out in this example. We'll do another example in a few minutes where we will factor out a greatest common factor. But in our case, there is no greatest common factor. Let's go to step 2. Multiply the coefficients of the first and last terms. That means multiply A times C. So let me explain what that means. So here's the expression they're giving us. I'm going to compare this to ax squared plus bx plus c. When I do that comparison, I'm noticing our a here matches up to 5, our b matches up to 11, and our c matches up to 6. So step 2 is telling me to multiply a times c. So in our example, that's 5 times 6, which is 30. All right, so it says find two integers, that means two whole numbers, whose product is a times c and whose sum is b. Notice our b number is 11. So what step 3 is asking me to do is find two numbers that multiply to 30, that's the AC part, but add to our B number is 11. So let me think about this. What are two numbers that multiply to 30? Let me list out all the possibilities. I could use a 1 times 30, 2 times 15, 5 times 6, and 3 times 10. So these are numbers that multiply to 30. But which pair of numbers here add up to 11? Well, there's only one option. These numbers add to 11, so I know I want to use 5 and 6. All right, it says rewrite the middle term as the sum of the two terms who are the coefficients of what we found in step 3. Let me explain what that means. What we're going to do now is take, let me make a little more room here. I'm going to take 5x squared plus 6x and rewrite the 11x using 5x and 6x that we just came up with. So here's what step 4 is telling me to do. Step 4 says, take the middle term 11x and rewrite it as 5x plus 6x. Well, I could do that because 5x plus 6x is the same as 11x, so that's allowed. Now it says factor by grouping. Let me remind you what factor by grouping means. You probably worked on some examples in Objective 1. Factor by grouping says look only at the first two terms to begin with. And I'm going to factor these only to begin with. Well, for those two terms that I circled in green, I'm noticing 5x can come out in front. And if I factor out a 5x, I'm left with x plus 1 in the parentheses. Then factor by grouping says, all right, also go to the back two expressions and factor these. It's almost like you're factoring the front two expressions separately, and now I'm going to factor the back two terms separately. Well, for these back two, I'm noticing that a 6 can come out in front. So I'm going to take a 6 out. That leaves me with x plus 1 in the parentheses. Now, the last step is to recognize that x plus 1 is in common. There's a parenthesis x plus 1 here and another parenthesis x plus 1 there. I can actually factor that out in front. So let me pull out an x plus 1. If I do that, I'm left with the 5x here. And if I factored out this x plus 1 here, I'm left with the 6. So here's my answer. My answer to this factoring is x plus 1 times 5x plus 6. Okay, so in ALEKS, what they wanted you to do is fill in these boxes and put a 5x here and a 6x there. And then down in this bottom area here, they wanted you to write the actual final answer of x plus 1, 5x plus 6. All right, so this method is called the AC method. What it says is take the A number and multiply it times the C number. In our example, that said multiply 5 times 6. That got us 30. So then you want to try to look for two numbers that multiply to that AC number, which was 30 here, but add to the B number. Our B number was 11. And it turned out in this example, the numbers 5 and 6 fit those conditions. So I knew to take the 11x here in the middle and split it up to be 5x plus 6x. Then you proceed with this factor by grouping method. All right, so this is called the AC method. Let's do another example from ALEKS. How about if we come here? This says factor a quadratic with a negative leading coefficient. So what that means is they're giving me an example where there's a negative number in front of the w squared. Well, to do factoring like this, like we just discussed, I really don't want a negative number in front of w squared. I want a positive number there. So I'm going to factor out a greatest common factor and include the negative sign with what I factor out in front. Well, I'm noticing that 3 is a greatest common factor here. So if I look at these coefficients here, I'm noticing 3 is a greatest common factor, but I really want to factor out negative 3. The reason I want to factor out negative 3 is I don't want a negative sign in front of the w squared. So let me pull out a negative 3. All right, if I factor out a negative 3, what's left over inside the parenthesis? Well, I know negative 3 times this first box here has to get me back to negative 3 w squared. So I know that means I'm just going to put a w squared here. All right, let me go to the second box. Negative 3 times this middle box has to get me back to negative 18w. Well, that means I should put a 6w here. Let me double check. Negative 3 times 6w gets me back to negative 18w. Let me go to this final box back here. Negative 3 times what number gets me back to positive 48? Well, in order for me to get back to a positive 48, I'm going to need a negative here, because a negative 3 times a negative number will get me back to a positive 48. And what number should I actually put back here? I think that's going to be a 16. Okay, and the double check is take negative 3 and multiply it back inside the parentheses, and you'll see you get back to the starting expression. All right, but I'm not quite done yet, because I want to check if I could factor what's in the parentheses further. So let me write it down here. We have negative 3w squared plus 6w minus 16. I'm going to try to factor this as two parentheses multiplying. All right, well, I know I should put a w and a w in front, because I know this w times that w will get me back to the w squared. Now I need two numbers back here that have to multiply to get me negative 16. So this number times this number has to get me back to negative 16. Well, if two numbers multiply and get a negative answer as a result, one has to be positive and one has to be negative. Right? The only way I can multiply two numbers and get a negative answer is if one number's positive and one number's negative. All right, so let me write out numbers that multiply to get me negative 16. All right, let me list out some options here. I could use -1 and 16, or I could use +1, -16. Okay, I could use -2 and 8. I could use 2 and -2 and -8. Again, I'm writing out two numbers that multiply to negative 16, and I could do -4 and +4. So which one of these options? Well, I need the option that adds to get me this +6 in the middle. And the only option where the two numbers add to get me +6 is this option right here. So I need a w +8 and a w -2 like that. Again, if I wanted to double check my answer, I could multiply back through the parentheses and convince myself that I get back to the original expression that I started with. All right, so this is having a negative leading coefficient, and you want to be sure to factor out the negative sign as part of the greatest common factor, because then you'll end up with a positive w squared or a positive x squared, which makes the factoring much easier when that w squared term is a positive value. All right, so why don't we, how about if we look at one more here? It says factoring, and this one says factor completely. All right, when they say factor completely, what they're really asking me to do here is first check for a greatest common factor. You know, and this is always the first step. Anytime you do any factoring problem, the first step is always checking for a greatest common factor. So let's look at the numbers to begin with. What's the largest number that evenly divides into 4 and 32 and 64? Well, I'm noticing 4 can evenly divide into all of those, so 4 is going to be part of the greatest common factor. All right, now let me look at the variables. Well, I'm seeing an x to the third, an x squared, and an x. I'll write it as x to the 1. Well, when you're factoring out a variable, you factor out the smallest exponent you see. So I'm going to factor out an x to the 1. Just x, or I'll write it as x to the 1. All right, so let me pull out 4x to the 1. Now I got to figure out what's left over inside the parentheses. All right, so I need 4x to the 1 to multiply this box and get me back to 4x to the third. Well, 4x to the 1 times x squared would get me back to 4x to the third. You know, I'm using the property here that says if you have x to an exponent, multiplying x to another exponent, this is where you add the exponents together. So x to the 1 times x to the 2, I would add those exponents together to get x to the 3. All right, let me come to the next box. I need 4x to multiply some quantity and result in negative 32x squared. Well, if I put a negative 8 here, 4 times negative 8 would get me back to that negative 32 part. And I also need an x, so that x times x gets me back to that x squared. All right, let me go to the last box. I need 4 times some box here to get me 64x. Well, I'm going to put a 16 here, right? Because 4x times 16 would get me back to the 64x. All right, so let me write this. We factored out a 4x. That means we have x squared minus 8x plus 16. All right, well, now I'm not done yet because I still have to try to factor what's in the parentheses. I'm going to try to factor it as two parentheses being multiplied. I'm going to put an x and an x in front because this x times that x will get me back to this x squared. All right, now in the back here, I need some number multiplying another number to get me positive 16. But then the numbers have to add to get me negative 8. Well, I need two numbers to multiply to positive 16. But I know they also have to add to negative 8. Well, that tells me that the two numbers have to both be negatives. Because if I take a positive times a positive, two positive numbers are never going to add to negative 8. So I really need two negative numbers to multiply to 16. So I could use -1, -16. I could use -2 times -8, or I could use -4 times -4. But I need the two numbers to add to -8. So the only option that does that is -4 and -4. These other choices would not add to -8. So I'm going to put a -4 and a -4 here. So and you can't forget the 4x in front, right? That's part of the expression. So the final answer here is 4x times x minus 4, x minus 4. And again, if you wanted to double check your answer, you could multiply this back together and convince yourself you got back to 4x to the third minus 32x squared plus 64x. Okay. All right, folks, hope this is helpful as you're working in Objective 2. Please email me if you have any questions, and I'll be glad to help.